This is the Math 107 Lesson 1 activities. We're going to simplify all of these problems that involve exponents and radicals. They cover a wide range of skills, vary in difficulty. So that's what this video is for, in case you got stuck while trying to remember all these many rules that you've learned in the past. Okay, number 1, 2x plus 5 times 4x minus 7. This is a multiplication problem. You may have learned how to do this in a variety of different ways. There's FOIL, there's a box method where you draw a box, there's the lobster claw, but ultimately you just distribute everything in the first parentheses to everything in the second parentheses. So I'm going to distribute the 2x to both terms in the second parentheses. So 2x times 4x is 8x squared. 2x times negative 7 is negative 14x. And then I'm going to distribute the plus 5 to both terms in the second parentheses. So 5 times 4x is plus 20x, and 5 times negative 7 is minus 35. And then we combine like terms. 8x squared minus 14 plus 20 is plus 6x minus 35. Okay, number 2, what's different here from number 1 is that this is a subtraction problem as opposed to a multiplication problem. So 2x plus 5 minus 4x minus 7. So I have to start by distributing that minus sign. That's actually like negative 1 times 4x minus 7. So I'm going to distribute the negative 1, and this becomes 2x plus 5. That doesn't change. Minus 4x plus 7. So that negative 1 gets distributed to both terms of the parentheses. And then we combine like terms. 2x minus 4x is negative 2x. 5 plus 7 is 12. Number 3, the square root of 1 over 49. The rules about square rooting a fraction are that you can square root the top and square root the bottom separately. So this is 1 over 7. Number 4, simplifying radicals. So I'm going to simplify each of the radicals before I try to do the subtraction, the 3 root 12 minus 5 root 27. Simplify the radicals first. So root 12 is not a perfect square, so I can't just take the square root. So instead, what I'm going to do is look for factors of 12 that are perfect squares. So you just go through the list in your head. The perfect square is 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16. So do any of those numbers, 1, 4, 9, 16, go into 12? 4 goes into 12. So I'm going to rewrite 12 as 4 times 3. And then the root 27, 27 is not a perfect square, so I want to see, does it have any perfect square factors? 1, 4, 9. 9 is a factor of 27. So I'm going to rewrite 27 as 9 times 3. And then I can take the square root of the perfect square factors that I figured out went into my two numbers. So this becomes 3 times the square root of 4 times the square root of 3 minus 5 times the square root of 9 times the square root of 3. And then the square root of 4 is 2. So this is 3 times 2, which is 6 square roots of 3. And then the square root of 9 is 3. So 5 times 3 is 15 square roots of 3. And then 6 minus 15 is negative 9 square roots of 3. Number 5. 72, if that's not a perfect square factor, then I want to see, does it have, sorry, if it's not a perfect square itself, I want to check and see if it has any perfect square factors. So I would check 1, 4, 9. 9 goes into 72, but I'm going to keep checking. I want to find the biggest one possible. 16, 25, 36. 36 is a perfect square. It's 6 squared, and it goes into 72 twice. So I'm going to rewrite the 72 as 36. And then I have an s cubed. S cubed is not a perfect square, but S squared is. So I'm going to rewrite S cubed as S squared times S. And then the square root of 8, I want to rewrite the 8 as a product of two numbers, one of which is a perfect square. So it's going to be 4 times 2 times S. And then you can take the square root of each factor separately. So the square root of 36 is 6. The square root of S squared is S. And then I still have a square root of S that can't be simplified. In the denominator, the square root of 4 is 2, and I still have the square, oh, I forgot the 2 in the numerator for the 72. Start again. Okay, so 72 was supposed to be rewritten as 36 times 2. And then S cubed is S squared times S. And then in the denominator, I have the square root of 4 times 2 times S. Okay, now take the square root of each factor separately. So the square root of 36 is 6, and the square root of S squared is S. And then what's under the radical, I still have this 2 and this S that can't be simplified. And then in my denominator, the square root of 4 is 2, and I still have a 2 and an S under the square root that can't be simplified. Those cancel. And 6 over 2 is 3, so this simplifies to 3s.